Welcome to today's webcast. This call is being recorded. And now to begin the program, I'd like to introduce Chris Flack.
Hey, thanks so much, Vicki, and welcome everybody in our audience to today's webcast, The Secret to Lightning Fast Failover. Faster Failover starts with a faster cloud. Sponsored by Infrascale. I'm Chris Flack with virtualizationreview.com, and I'm here to be your host for today's event, so thank you all for joining us for today's program. We greatly appreciate it. Now, just a few quick reminders before we begin today's call and get everything underway, just a couple quick reminders. So first things first is we are recording today's event for future viewing and listening purposes, and we'll send you a link to the email you registered with within about 24 to 48 hours after today's show. Please feel free to share that link with coworkers, colleagues, friends, anybody who may be interested on today's topic. We'd appreciate that. You can actually go down to the little dock down there on the bottom of your screen right now. You can click on the paper airplane icon. Excuse me. And you can actually send a link to a coworker right now. They could join you in the console. You could have a private chat together. It's quite a bit of fun. I suggest you all try the feature out. It's a lot of fun for a webcast. We also will have a Q&A session at the end of today's call. Please feel free to enter your question at any time using the Ask a Question box on the left-hand side. We'll try to get to as many questions as we can during the program today. If we don't get to all the questions and we don't get to your question, don't feel bad. I'll make sure that somebody from Infrascale gets in touch with you after the show is over, so that way you can get your question answered. Really briefly, before we started today's program, we had a poll question for everybody in the audience. You could actually interact with the slide on your screen to answer the following poll question. So we were curious, what are you using the cloud? Are you using the cloud for more than 50% of your business applications? Your options are yes, no, or not sure. I'll give everybody a couple seconds to answer that following poll question while I introduce today's speaker on today's call. His name is Stefan Sima. He has over 20 years of experience in leading technology and product management teams, both at tech startups and large software companies. Prior to joining Infrascale, he led efforts to make PassLogix, an industry leader in the enterprise security space, to be recognized by Gartner and purchased by Oracle. He is fluent in French and Spanish and received a BS in Aerospace and Mechanical Engineering from UCLA and an MBA from Columbia University. He is passionate about aeronautics and holds a personal pilot's license. Now, I'll give everybody another couple seconds just to answer the following poll question you see there on your screen. Are you using the cloud for more than 50% of your applications? And as we've got a bunch of answers, I'll push those out to the audience. And at the same time, I would like to welcome Stefan to the floor. So look, we have 77.8% of the people chiming back with a no for today's presentation. Thank you all for participating in today's poll. And without any further ado, I'll hand everything over to Stefan, so that way he can get started. So please take the floor.
Great, Chris. Thank you very much. So we'll skip right by the photograph there of me and move right into the agenda. So interesting to see the results of the poll saying that basically most people on the line are still predominantly using on-premise-based applications with probably some mix of cloud-based apps at the same time, which is fine and very appropriate for what we're going to talk about today. So today what we're going to talk about is a few things. Number one is threats to business continuity. Business continuity here, in the broad sense of the word, of whether it's data or applications or whatnot. How the cloud changes disaster recovery. Then talk a bit about Infrascale and the Google Cloud. We recently announced a partnership here which has some unique bearing on DR. And finally, as Chris mentioned, we'll do some Q&A. So let's jump right in. When we think about uptime and downtime, what are the threats to your business continuing normal operations as relates to our IT computer systems? There's really sort of three things we think about. The first one, the one that's been around for as long as computers have been around, is the loss of data. So we'll talk a little bit about that. Then we're going to talk about a more recent phenomenon, which I like to call data hijacking by ransomware in this case. And then lastly, we'll get to talk a little bit about true disasters and downtime that can come from there. So in terms of data loss, as I mentioned, pretty much everybody knows that data loss has been around as long as computers have been around. And for as long as computers have been around, we've always been looking to do things to mitigate or prevent data loss or recover the data if it is lost. And yet to this day, these statistics that you see on the screen here are very recent statistics. Data loss still occurs very, very frequently. And that might be user data that gets lost. 1 out of every 4 users loses some data every single year to one reason or another. It might be somebody who leaves their laptop somewhere. Somebody rushing out of a cab to the airport and forgets their laptop against their, in the taxi. Or as more recently happened to me, I lost my iPad on an airplane because the cover blended in with the colors of the seats in the airplane and I couldn't see it and walked out without it. More severely, there can be some big instances of that. Some of you may know that a while ago there was a really good movie called Toy Story by Disney, a company and Pixar, a company that takes a lot of effort to really protect their data. And at one point, they completely lost the movie. Like, it was in the middle of production, almost towards the end, and completely lost it. Backups didn't work, and it's only a saving grace that they had one employee who had received permission to work from home and had taken a copy of the movie at home so that she could work on editing it, that they were able to recover the movie at all. So notwithstanding how old this is, this problem continues to this day. The next threat is what I call data hijacking. And basically, I think now we're all more increasingly familiar with this threat. Basically, it's a form of malicious software, malware, that will get onto a target computer system and begin to encrypt the data. In the older days, meaning just a few years ago, it might encrypt the data all very quickly, all at once. These days, it'll tend to fly under the radar and encrypt the data more slowly, or encrypt data while still allowing the user to access the files. So the user thinks the data is fine, and then when enough of the data has been encrypted, bam, all of a sudden, the next time you try and access a file, you get a friendly little note on your computer screen that says, go over here to buy some bitcoins in order to get continued access to your data. Basically, you've been held up for ransom. I can tell you that here at Infoscale, I personally sit right next to a lot of our customer support reps, and I can tell you we get a lot of calls from people that have been victims of ransomware. Obviously, they're calling us in order to help get their data back, which we do all the time. But it is a very, very frequent occurrence these days. It's literally become a billion-dollar business. In this stat right here, you see $200 million in the first 3 months of 2016. That number is a year old now, and all of 2016 was over $1 billion, and even more now starting in 2017. The other thing that has happened is, whereas ransomware initially started really targeting end users and their own personal machines, the perpetrators of this threat have gotten smarter, and now they go after businesses. Healthcare seems to be a target they really like for some reason, and they go after business data or business systems and try and encrypt that stuff. And then obviously the money they demand is much higher, and so for them it's a way to increase their revenues. Okay, and then lastly, the other threat is downtime. And downtime here really means when systems go down. This could be something that happens relatively frequently on a more local level, so things on the left that we here at Infoscale will sometimes call a micro disaster. You may also think of it as, system outage. A hardware issue, RAID controller fails, disk crashes, power supply goes out, something like this. Could be a software issue, a traditional virus, not necessarily of the ransomware kind, but a virus that creates all sorts of damage. I've seen, in my time, I've seen large companies, very large companies. A few years ago, one of the top 3 auto manufacturers that literally for 3 days could do nothing other than try and fix their systems because of a virus. It could be a human issue. It could be an employee, a happily employed employee who just accidentally deletes data. Could be a very unhappy, disgruntled employee who maybe intentionally does something like wiping drives on his way out. Or it could be some sort of local environmental issue, right? Could be a power outage due to a local storm or to something like this. So these things are, relatively small in comparison to natural disasters, maybe only affecting one company or one site of a company, but nonetheless they happen more frequently and are an issue. On the other hand, are the big things, right? Things that are, natural disasters that maybe only happen once in a while. For most of us, we may never experience one, depending on, what part of the world we live in. For others, maybe if you live in Florida or if you live in Oklahoma, this could be a regular occurrence where there's, always some hurricane or some tornado that is coming through. And these are the kinds of things that cause wide-scale damage and downtime, and business can be down for days or weeks because of this. And it's, even though sometimes it's, it's only once in a while, in aggregate, it's pretty prevalent, right? You can see some of the stats that we're showing you here. We regularly, look at these kinds of research reports just to keep our pulse on, what's going on at a broad level. In these most recent ones here, 91% of the people surveyed had a data center outage in the last 2 years. Almost half of them have had an outage or some sort of downtime just this year alone. And again, on the right, you can see the prevalence of some of the causes I spoke about in the previous slide. Starting off with hardware failures as sort of, the one that happens most often, natural disasters being the one that happens least often, but typically causes the most amount of damage. And depending on how big your business is, or that of your clients, the cost of that can be more or less, right? For a small business, maybe it's only, $8,000 an hour, whether it's lost revenues or lost productivity or whatever. But as you get into, medium enterprise, mid-market, then to large organizations, it can get over $500,000 an hour anytime something's down. So this definitely has, real potential impact on revenues and profits. Okay, so we've sort of set the stage now, talked a little bit about, three major causes of downtime that are IT related. And so let's talk a bit about what we can do about them. And really we'll talk about them, in this case, in the context of using the cloud as part of the solution to these problems. So we'll talk about backup and recovery. We'll talk about a new trend in defeating ransomware or mitigating ransomware that Infoscale kind of pioneered, called anomaly detection. And then lastly, we'll talk about disaster recovery as a service. So starting with backup. So backup basically is making a fancy copy of all of your data and storing it somewhere safe, so that if something should go wrong, you could always recover it. In the old days, this was done with tapes that were, then shipped off-site, stored somewhere safe. Then after that came a cycle of people using software tools that would back up the data, make a copy of it, and you'd store it on, separate drives, disks, drives, USB sticks, or whatnot. And then came a third wave where now data is really being backed up to the cloud, okay, which is one of the things that Infoscale offers as well. And so in this case, user data, be it, endpoint data like laptops or phones, or server data or desktop data, all this can be captured and then stored up in the cloud safely, obviously keeping multiple versions of it as it changes over time, so that it can then be restored, if necessary. Now, the cloud brings certain benefits to backup and recovery that other form factors, if you wish, do not. One of the things that it does is that it enables users to retrieve lost data from wherever they happen to be. So if I happen to be on a business trip and I lose data from my laptop, I can recover that data directly from the cloud wherever I happen to be. So that's a flexibility of location and time, frankly, that is not necessarily available if I'm using other kinds of solutions. Another benefit that comes with using cloud for backup and recovery is that it's really good for things with intermittent connections to the network. If, again, I'm using a laptop or something like this and I'm traveling and I'm not always connected, whenever I am connected to the internet, then the backups can happen, and when I'm not, then that's fine, and then it picks up again when I'm connected again. Unlike other solutions where it depends on either a permanent connection or access to hardware or whatever it is in order to run that backup, here this is sort of always on, whenever you happen to be on. So those are two of the benefits that uniquely come from having things backed up to the cloud rather than, say, to local drives or anything like this. So having set the stage with backup, let's use that to transition to what we can do about ransomware. So the best way to work around ransomware is really through a three-step approach. Obviously, the first step is continuing to train users to recognize and not click on those nasty links, right? If users never clicked on a bad link, we'd never have a problem with ransomware. And yet, as much as we train people, as sophisticated as people are now getting, in computers, everybody has one, it still happens, right? And so education is obviously the first step, but the first step is not enough. Second step is obviously a leading antivirus, anti-malware solution installed that can detect, malicious software, as it's trying to come on before it actually gets onto systems and try and prevent the attack from occurring in the first place. However, even with these two steps, there can occur situations where, malware gets through, right? Ransomware gets through. And so then what? So then you're left with one of two choices. You could either pay the ransom and hope you get your data back, or you could try and recover the data from a version of that data before the ransomware actually hit. If you've been doing good backups, you can always step back in time to a point before the ransomware hit and recover the data. Okay? Now, any good backup and recovery solution will do this for you, right? Whether from Infrascale or anybody else. However, we've sort of taken it to the next level. And what that means is that when we're continuously backing up data, we can monitor for how frequently those files are changing, right? We obviously are backing up each version of the data as it changes. And so we can track, how often is this data changing? And we can let the administrator set certain thresholds around how fast that data is changing. Is it changing, around what it's been doing on average, or all of a sudden there's some huge spike and hundreds and thousands of files are getting changed, and historically this particular user only changes 10 files a day, right? So by looking at the change rate of files as we're backing them up, we have an early warning sign as to whether or not something fishy might be going on, whether some sort of anomaly is happening that all of a sudden all these files are changing, right? And so in doing that, we can alert the administrator or whoever early, before the ransom actually is presented, right? If we can detect file change and send a notification before it has really encrypted too many files, before it is spread across users, before it is spread to servers, we might be able to stop it, roll back before we actually ever get hit with a ransom, and therefore avoid paying the ransom, avoid having to lose more data, and avoid downtime. So this is a unique value add that we bring to the party, basically extending what is a traditional cloud-based backup and recovery solution to mitigate and help remediate today's threats. Okay, so now let's move on to the third topic here, which is disaster recovery. So disaster recovery is not just about recovering people's data. It's also about getting systems back up and running should they go down. And in the old days, there was no difference, right? In the old days, your backup was your disaster recovery plan. If your system crashed and you had to rebuild everything, you hoped you could go get a tape and restore and somehow you'd be good. And that was cheap and took a long time to do. And then came out things like cloud backup and appliance-based backup, which basically did the same thing, right? You would do a bare metal, backup of the entire disk of the system, and then if that system went down, you would restore from that full, bare metal image and get everything back up and running again. And that, cost a little bit more, but shaved down the amount of time it took you to recover. It still might take, a few hours, several hours, but it was a lot better than taking days. Then, for those that can afford it, so the large enterprise of the world, you start getting into people that will do, really set up second data centers or second sites, right? Basically, if I have one computer center, I'm going to build a second one, just in case. And that way, if my first one goes down, I can flip over to my second one. And that second one, it might be a cold site, so it's not actually processing any data. It's just ready to fire up in case I need it. A warm site where maybe the power is on and the systems are, ready to go, but it's not actually processing any data. Or a hot site where it's literally, it's processing data, it's really, transacting at the same rate as the production one, so you can flip between them very quickly if you have to. As you can imagine, this is expensive, right? This is really expensive. It's basically 2-for-1 costs for whatever you're trying to get done. And so really only the largest companies had the budgets for this kind of a thing. And frankly, by and large, they were the ones that historically had the need for this kind of a thing. If you're a large bank and you're processing checks and credit cards, you're the candidate for this. The challenge comes up, however, that a lot of other businesses also want or need this kind of recovery time. Now, they want to be able to recover, in hours or seconds, not days, right? Increasingly, as the world of business gets faster and faster, even among, small to medium business or mid-market customers, a few years ago, recovering in 8 hours was acceptable. Now it's out of the question, right? Now it's got to be, 4 hours or 15 minutes or whatever. And so how do you accomplish that? That was sort of out of the reach for businesses like that. But two things changed that, right? Two things really made a change. And what people really want is to be able to recover in seconds without spending that kind of money. So that's the nirvana that we talk about. And the two things that make this possible now are cloud and virtualization. So cloud, because really underneath the hood, cloud is a shared infrastructure. So I, as a business, don't have to pay 100% of the cost for that second site. I can share that cost with a bunch of other clients and only really pay for it as I need it. Okay? So that's the first thing. And the second thing is virtualization technology, the ability to capture physical server systems, virtualize them, do work under the hood so that they'll run in a virtual environment even though they were not originally installed that way, have them run in the cloud as if they were still on the original machine. Those two things create the possibility to offer a disaster recovery solution that doesn't require dedicated, reserved infrastructure, but really can run on demand. And that is, in fact, what is disaster recovery as a cloud-based service, as a service. And so if you look at it on this chart really tries to make the difference between backup and DR. So in the old days, whether you were looking at tape or disk-based backup, you made a backup of the system, and then you stored it in a safe place, and then if you had a problem, you would retrieve that copy if it was tape, and then you would restore it, and that restoration process might take hours or even days. And once that was done, then you could get your systems up and running again, and then you could continue your business. And so that whole process might take hours and days. What disaster recovery does is flip the run and the restore steps. So take a backup. When you have an issue, you run straight from that backup wherever it happens to be located. And then once the disaster is blown over or the outage has been taken care of, restore back on your own time. So the whole end-to-end restore process might still take a fair amount of time, just like the other two, but the time to run is actually down to minutes or seconds because you're running immediately before you even try to do the restore. And so that's what creates the ability to really reduce recovery times and get people back up and running quickly. So to show you in sort of a user workflow how this happens, here I'm showing you an end user who is doing computing on various computing systems. This particular company buys a cloud-based disaster recovery solution. This is a hybrid cloud-based solution. So in this scenario, there's an on-premise hardware-based appliance that's installed locally, as well as a cloud-based component. Okay, and this together comprises the disaster recovery service offering. And the reason for hybrid architecture here is I can capture the systems, the replicas of the systems locally, so I can do it at high speed. I provide a redundant computing resource right on site. I can do all of the processing I need to do, like deduplicating the data, compressing the data, and then replicate that to the cloud. In doing this, I end up having two redundant copies of my systems, one locally and one in the cloud. Pretty much as I described right here. So now let's suppose that I have a micro disaster, right? I have a system that fails or something like this. The administrator can basically push a button, in this case, on the local failover appliance, bring up a virtual replica of that system right on that local appliance, and the users now can keep on working. Let's suppose, however, that I have a natural disaster. So it doesn't just take out one system, it takes out all systems, including the local appliance, all at once. So now I can't use anything locally in order to recover. So in this case, the administrator will again click one button, only this time he'll be doing it in the cloud instance, and this will bring up the computing environment that was the production environment, will bring it up in the cloud. Now in our particular case, when we say click a button, it's literally that easy. And whether we're talking about bringing up one system or a group of systems or an orchestrated workflow of systems where you have to bring them up in a particular sequence and wait for certain systems to be up and running before you bring up the next ones, all this occurs automatically. Brings up a whole replica of the environment and then redirects the users who can then continue working with a cloud-based instance of their systems. So InfoScale offers two cloud-based services. One is InfoScale Cloud Backup, the other InfoScale Disaster Recovery. And as their names imply, one is really oriented around data backup and recovery and ransomware mitigation, and the other one is around disaster recovery. Both are cloud-based services. One on the left, Cloud Backup, is a direct-to-cloud service. There's no on-premise components. Disaster Recovery is a hybrid cloud offering that has an on-premise hardware or virtual appliance that gets installed on-site, virtual meaning just a virtual machine software component, as well as a cloud-based component. And so together these provide coverage for basically all of the rings that will define a company's infrastructure. So by rings, what I mean is that the outer ring you have endpoints of laptops, come a little bit on the inside, the inner ring, and you've got remote office servers, branch office servers, things like this. Come in a little bit closer in the third ring, towards the center, and you've got more mission critical systems, and then at the very center you've got the core mission critical systems without which the business just doesn't run. And so you need to have a protection strategy for all of these systems, and with these two services we can give that. Okay, so with that, we'll transition to Chris for our next poll question.
Yeah, thanks so much. So for everybody in the audience, if you wouldn't mind actually interacting with the slide on your screen. So the following poll question is, which problem are you primarily looking to address with the cloud? Disaster recovery, ransomware mitigation, or compliance headaches? I'll give everybody another couple seconds to answer the following poll question before we continue today's program. And just a reminder, before we get back on with the presentation and show the results of the poll, that if you have a question for Stefan, please feel free to enter it at any time. And we'll get to them as we can during the Q&A session at the end of today's call. Okay, let's see here. We've got some results, and we have 84% of the audience coming back in with disaster recovery, something that they're looking to address with the cloud. So thank you all for your participation in today's poll. And Stefan, I'll put you back into your presentation right here to continue on. Thank you so much.
Excellent, thank you. Okay, so now let's change the channel just a little bit. Up until now, I've been talking about backup and disaster recovery in terms of how they work and so on, and I haven't dived too much into sort of architecture. So we'll do a little bit here. So at least with our services, we provide users with choice as to where what kind of cloud they want to use. InfoScale runs its own cloud with its own data centers around the world in order to provide backup and disaster recovery resources. But we also have always believed in providing users with the choice of cloud. They could use our cloud, they could use a private cloud of their choice, or they could use a public cloud, the leading names that we all know. Among those partners, we started working very closely with Google about a year ago. What started about a year ago as just a business conversation around what we might do together really evolved into a technical collaboration that then resulted in a unique capability between the two companies, which was announced last month in January. And so, the ability to work with public clouds suits some users. You guys maybe either already have a Google account and you want to leverage it for many things. You like the idea of using a public cloud. Maybe you like the idea of Google's cloud. You've heard what they're doing and it suits you. And when we looked at Google Cloud, we found a number of things that the Google Cloud does that were uniquely relevant to disaster recovery. And I'll talk a little bit about those now. So typically when people think about cloud, they typically think about two things. They either think about, okay, I'm going to use a cloud-based application, like a leading sales sales automation system, or a leading set of financials, or a leading HR system that happens to be a cloud-based application, a SaaS app. So that's one thing they think about. The other thing they think about is, I'm going to move or have some of my computing workloads just run in the cloud. I'm going to use that. I'm going to have a virtual private server or something like this, or I'm going to use a cloud-based infrastructure, and I'm going to install, build and install and run my environment there. And so once I've built it, installed it, it just basically runs there, and that's it. DR, on the other hand, is a slightly different use case. Okay, I want to be able to take systems that are running on-premise, whether on physical servers or in a virtual environment that I run. I want to replicate that to the cloud, but I don't want it to run there. I just want it to stay there, just in case something goes wrong, right? In case I have a disaster. And if and when something goes wrong, then I want to be able to fire those systems up in the cloud really, really quickly. The more quickly I can fire it up, the less downtime I'm going to have. And so that's a different thing. You need a public cloud that doesn't just run things with lots of resources or scalable resources, but also one that can boot things really quickly. In our experience, certain public clouds don't give that. It might take up to 4 hours to get a virtual machine instance up and running. And it's not predictable. It might be 4 hours one day, it might be 2 minutes the next day, or whatever. So you can't even provide a reliable, service level to your users. What we found with Google is that things boot really quickly, consistently, and so the virtual machines were booting within 40 to 50 seconds. And that's really, really important, because when we offer a 15-minute RTO guarantee to our users. Basically, we say, if you have an issue and you have to boot up one of your machines in our cloud, or a group of machines in our cloud, any one machine you want to boot will be running and ready for login in 15 minutes or less. And our actuals are actually much faster. They're actually down around a minute. So we want to be able to continue doing that. In our cloud, that's not a problem. And as it turns out, in the Google Cloud, it's not a problem either. We found that when we ran our benchmarks, performance we were getting out of the Google Cloud in terms of running, booting and running VMs there, it was pretty much as fast as running on bare metal in our own cloud. So that's very, very good. We found, obviously, local SSD really helps. One of the things that happens in DR is you're taking a number of systems that in normal operations are running on their own dedicated hardware, or are running in dedicated virtual machine resource instances, that now all of a sudden are having to be fired up either on a local appliance, which is not as big as the original environment, or in a cloud where the resources that are allocated may not be what was originally spec'd out for the production environment, and you have a lot of applications competing for disk access, for example, right? And so having a really fast local disk, local SSD, high throughput, low latency, all that stuff really matters, and it matters more even for DR. The second thing that we found is that the Google Cloud was very scalable. And when people think about scaling, they tend to think, okay, the amount of resource that I need, computing resource, can go up and down as I need it to. And that's absolutely true here as well. However, there's some additional things that come in terms of scalability that are useful for DR. In the DR case, again, we're taking machines and workloads that originally are somewhere else, replicating them up to the cloud, virtualizing them, and then running them. Okay, and they may have different specs. You need a certain amount of RAM depending on what the app is, a certain amount of storage, a certain amount of CPU, whatever. And just having gross T-shirt sizes in terms of what I can spec on my virtual computer or virtual environment sometimes isn't good enough. I'm either under-speccing or over-speccing, right? I'm under-resourced or I'm paying too much. And so the ability to have custom machine types where I can dial in very granularly what kind of resources I want for virtual environments, this is actually really good. Also, another thing that's relevant is really fine-grained billing, so minute-level billing, right? Many cloud environments bill you by the hour, by the day, by the month, depending, And if you're doing continuous computing in the cloud, that's fine, right? In fact, you want the discounts that come from that kind of volume. But if you're doing DR, if you're just doing DR testing, right? For example, you want to bring something up just to validate that you can actually fail over in case of a DR event, you might only be up for 45 minutes, or 7 minutes, or whatever, 53 minutes. And you'd rather just be billed for that and not for a minimum of 2 hours or whatever. And so this kind of fine-grained billing actually plays, it's uniquely suited to the DR use case. A third thing that is relevant is scope, right? Where you have points of presence. In these days, what we find is that a lot of countries have put in place data sovereignty laws. And data sovereignty laws basically say that, businesses have to keep their data in their country, right? Especially if it's private user data, privacy-related information, sensitive information, whatnot. They want that data to stay in their country. They don't want it going to another country where it might be exposed. So a lot of countries now have this, which means if you're going to use cloud, they need to have a point of presence, where the data is kept in that country. Okay, and so we ourselves provide locations in a number of parts around the world. This chart here, the red ones show where we have points of presence. The blue and the green ones show where Google has it. Right, and what's interesting here is that although there are areas where we complement each other, so for example in Australia and Brazil, which is good because we provide redundant locations in country, they also covered a lot of different locations that we did not, and so this allows us to offer cloud-based disaster recovery services to companies in countries where we otherwise would not be able to. And so this is an interesting point, right? If you're looking at a cloud-based disaster recovery solution, regardless of whether it has all the features that you want it to have or not, in some countries, if it doesn't keep the data in your country, you just can't use it. And so that's a thing to think about. At a architecture level, I'll just describe this very, very briefly, how the joint solution works together. At the lower level here, you'll see the source systems that we are protecting. So it might be Windows desktops, MacBooks, iOS phones, what other endpoints we might have. Might be Windows, Linux, or even Unix physical servers. Might be VMware, Hyper-V virtual servers. So these are the data and the systems that we want to protect. And so in the case of cloud backup, there's going to be a software agent on each of those systems to capture the user data. In the case of InfoScale disaster recovery, it's going to be either an agent for the physical systems, or in the case of the virtual environments, we're going to connect directly to VMware using its API for that. Or in the case of Hyper-V, we will install an agent. However, it is at the hypervisor level, not inside each of the virtual machines. So if Hyper-V is running 100 VMs, you're installing one agent in Hyper-V, not 100 agents in each VM. And in each case, we are capturing the data. In the case of DR, there's an on-premise physical or virtual appliance, which is doing a lot of the processing there in terms of deduping the data, storing a local instance of it. And then in both cases, we are also moving the data up into the cloud. Now in this particular case, it is into the Google Cloud. If I was presenting this as a generic a slide, it would just have the InfoScale Cloud or InfoScale and or public clouds. In this case, it's Google Cloud, which is also your second recovery point should you need, or location for recovery should you need to. And in any case, everything is managed through the central web dashboard, the InfoScale dashboard, both agent deployment and configuration, looking at what's going on inside the on-premise appliance, or working with Google Cloud. Okay, so with that, let me just do a very, very brief step back, a brief couple slides on who we are as a company. InfoScale is a company that is basically wholly focused on data backup, ransomware protection, and disaster recovery. This is what we do. It is all that we do. Our heritage is cloud. We have always started in the cloud, and we continue in the cloud. So that's something else that's sort of really in our DNA. We've been doing this since 2011, located in Los Angeles, California, right next to LAX. We have additional offices. We have a development center in Salt Lake City in Eastern Europe. We have some back office support operations in 2 different cities in India, and we have sales and support personnel throughout the United States and in Europe. You can see down on the bottom left, we've gotten a fair number of accolades, historically and even recently. One of those particular accolades was most recently by Gartner Group. As you guys probably all know, Gartner does a number of magic quadrants in different technology spaces during the course of the year. They do one for disaster recovery. And in InfoScale's first time out, included in this particular analysis, we were basically at the top of the visionary quadrant, i.e. people with a broad vision as to what the future is going to be, who can execute. Okay, so the last slide I was going to present here is just that we would encourage you to take this on a test drive. In order to do so, we're giving you a free trial and a $500 credit, which applies to your use of our solution. Try it out and see if this is something that you'd like to explore. So with that, I'll turn it back over to Chris for, I think, what's our final poll question.
Yeah, thanks so much, and I'll keep this up while we actually go through the Q&A portion of the webcast here, so that way everybody has time to answer the following question they see there on their screen. So as we close out, I'll keep that up on the screen for everybody as we close out the show. And just a couple of reminders, for those of you who asked about a copy of the slides, they'll be made available after the show is over, so that way if you want a copy, and the people that asked, will make sure you get followed up with after the show and see if you can get a copy of the slides, so that way you can have the information handy with you when you talk to other people about it. Okay, so we have a question here from the audience, and somebody was curious, what is your support like? Would you mind describing it?
So our support is offered on a 7x24 basis, 7 days a week, 24 hours a day, and it provides, phone support. We also have knowledge bases and other internet-based means as well. So, everything from how-to questions to, there's an issue and we need to resolve it for you. Support for us is a broader definition than just, what happens when you have a problem. For us, it starts at the very beginning. If you come on with us as a customer, we're going to do everything to get you set up properly. Everything we do, we charge on a flat rate, dollars per terabyte per month basis, and included in that is all of the support and services that you need. So, just getting you onboarded, we have a dedicated team of implementation engineers that work with you to install, configure, set up everything. We do your first DR test with you if you need, to prove to you that your systems can now be fired up in case of a disaster event. And then, when we turn it over to you, you're up and running. And so from the very beginning, we start off and get you on a right footing. And thereafter, any issues, obviously feel free to call our support, 7x24, with people located around the world, in the U.S. and in Europe, to help you.
I got a question here. This person's commenting, you've addressed a failover. What about failback?
Right. So obviously, without a failback, we've only done half the job, right? So failback is also very easy to accomplish. When you've got your systems, back up and running, you're going to, quiesce and shut down the environment that you've had running in the cloud or had running on the appliance, create a backup, if you wish, a recovery point from those cloud instances, and then restore those back to the original machines and the original environments. So that really is sort of high-level step-by-step how you do that. In virtual environments, you're going to restore it back to the environment that you were running in. In physical servers, ideally you're going to restore it back to the same hardware or the same type of hardware that was running it before. Can also work sometimes with different hardware that was not what was originally being used. That you have to work out a little bit to make sure that that's good, but that's literally sort of how it works.
And last question here before we close out the program for today. This question is, are you CJIS compliant?
Yeah, funny who's asking that. Yes, actually we are. One of the, so CJIS, for those who don't know it, if you are a law enforcement agency in the United States and you want to have access to the FBI database of criminal information, your systems must be CGIS, Criminal Justice Information Systems, compliant. And so if you're going to use the cloud for anything, such as backup or disaster recovery, the cloud you use must be CJIS compliant. Otherwise, you can't use it, or if you're going to use it, you can't get access to the FBI database. And so in our particular case, one of the data centers where our service operates is a CJIS compliant data center. So that way we can provide compliance for those users that need to do that. Typically, police departments, local, state, or federal agencies. Those are the kinds of users for that.
All right, excellent. Well, thank you so much for answering the questions that we got from the audience today and your wonderful presentation. As always, thank you so much. Just a quick reminder, I'll put this up there again for everybody in the audience. For next steps after today's program, you can follow what's here on the slide right there on your screen. I'll keep that up there for everybody to copy down as we close out the show today. But thank you all for attending today's webcast. The Secret to Lightning Fast Failover has been sponsored by Infrascale and brought to you by virtualizationreview.com. Thank you all for attending today's program, and we hope you have a great rest of your day. Thanks so much. Take care.
That does conclude today's webcast. We thank you for your participation.